Good evening, everyone. So, yeah, we'll begin our class. I hope I am audible.
Yes.
Thank you. So, in our last class, thank you. So, in our last class, we left at modules, and so we'll begin from there, and then we'll move on to a little bit of recursion. So, in our last class, we also talked about recursion, but I told you that we have one topic which is left on recursion, which will show how we can use recursion more efficiently, and then we'll move on to exception handling, debugging, and then file handling, maybe not today, in the next class. So this is what we'll discuss today. So what are modules? Modules are actually blocks of code which have been written by someone, and we can include that in our code such that we can use that code without have to write that code again. All right. So suppose you are working in some company and you are working in a team. So everybody has assigned some work and they write some code in a file. That can be any name. So I have written abc.py. So these files, when you import these files in your program to use that in your program, then these files are known as modules. All right. So suppose so a company is trying to develop a game. Somebody is working on sound, somebody is working on graphics and all. So if you want to include that file inside your program, you do that using import command, and whatever you are importing is called module. All right. So in the assignment one, I mistakenly gave you one rock paper scissors game. In that you had to import random module. So we'll talk about that also in today's class. So when you write import random, so random is a module which whose code has already been written by someone, and you can import and use its function, whatever attributes this module has. You can use those without worrying about what is happening in the background. All right. So I have I can import random by writing import random. When you do that, then you can use all the functions in random. So suppose you want to find a random integer between a and b. So you can do that using function randint, which is inside random. And how can you use that? You have to write random dot randint and a comma b. So suppose I am saying from 1 to 10, give me one integer between 1 comma 10 randomly. So this is what it means. From random module, you are getting one integer from 1 to 10, and that is done by this function called randint. All right. And when you execute this, you will get a random number between a and b, here 1 comma 10. All right. So whatever functions are there in this random module, you can easily go in website, so not website, in the internet and see random module Python. And when you search, you will get, see, this is Python documentation, and this is also a very good website, W3 Schools. Now you will see there are so many methods inside this random module, and as and when you require some methods, you can come here, look into it, and then use it. So there is a very good function called shuffle. So what shuffle does, it takes a sequence and actually it shuffles whatever inside the sequence is, and it actually changes the object itself. So what it means, let us see with an example. So suppose we have a list one. It is actually so I am using range here to do it. You can also just write 1 to something else. So I'm saying till 15. So there are 15 numbers, not 15. So for 15 numbers, I have to write till 16. So what is list one? You can easily check list one. And when you execute this, so you see what it is happening. When you say range 16, an object is created from 0 to 15 because 16 is not included. And I'm then converting it to list and I'm storing it to list one. So this is what list one is. Now, when you say random dot shuffle and you pass list one, then list one, so nothing is returned, but list one itself is changed. All right. So when you execute this, you see inherently all the elements inside list one is shuffled randomly. So if you execute this command again, another sequence will emerge, which is a shuffled version of this list. All right, because this is the value of list one when we have executed this command. So when you say list one and when you check, so you see it is again shuffled. So this is one function inside random module. Right. So there can be other modules also which you want to import in your in your code and use it. All right. So other can be math. So there is an important module inside Python called math. So you can say import math, and in this there are other constants, mathematical constants, and those values are stored in this module. All right, so you don't have to always assign some value for pi, say, or other values like h. Other values are also there, Planck's constant and so on. So you can have, when you import math, you can say math.pi. So when you do math.pi, the value of pi is being taken from that module called math. All right, so it is 3.14 and so on. Now there is a one more module which is called datetime. If you import datetime, just 1 minute. Yes, so there is something called datetime. It is a module which actually gives you the current date and the current time in your code. All right, so when
You are not audible, Shubham.
oh, I'm sorry. So am I audible now?
Yes, yes.
Yes. So I'm sorry. So I'm saying that there is a module called datetime, and when you import this module datetime, you can use the functions inside datetime to get exact date and time which the computer is perceiving. So over here, when we write this datetime.datetime.now, so what it is actually, this is the module name. This is an actually attribute of that module. It is like a function, or you can say, yeah, or variable, or attribute you can say, and this is the function called now. And when you do that, you will get today's date as and the time when this was executed. It was executed at 18:10, and this is seconds, and these are milliseconds. So you don't have to go inside that, but these are some modules which you can use, which are inbuilt in Python. All right. Now you can also see other modules here in the I have written. This is actually Python documentation. You can go there and you can check what are the other modules in Python. All right. Now you can also import some module using some alias or some short name. So there is some big module. There can be modules with big names. So there is a module called matplotlib. Matplotlib. So you see, whenever you called a module called math, you had to write math.pi. So you have to reuse this name again and again. So you called datetime, you had to write datetime.datetime. You called random, so you had to write random.randint. So you can reduce the typing by writing like this. So you can call a module. So I'm importing random again. Import random as rn. So when you write this, then you are not required to write random. You just write rn dot randint and give two numbers 1 comma 10, and this will do the same exact thing what this did. So random dot randint 1 comma 10 is exactly the same as rn dot randint 1 comma 10. Why? Because we have imported random as rn. This is just a name alias which we have given to random. All right. You can also do for math. So if you want to write import, or any other module you can rename. All right, so you can say import math as m, and you can say m.pi. So when you do that, you will get the same value of pi. Now you see these modules are huge, and suppose you just want to use one function inside that module. So suppose we just want to get only random integers between two numbers in a you are writing a program and you only need this function and no other function in random. So when you go to the Python documentation, you see so many functions are there inside this module called random. You don't require so many modules, you just require one function called randint. All right, so where is randint? Must be here. Yeah, it is here. So you just require this function randint. So you can also do that. You can just import one function from a module. How can you do that? You have to write like this: from random import rand int. Now you can just directly write rand int and say 1 comma 10. So this will do the exact same thing. All right, so you're just calling or importing one function from that module. Similarly, for date time, you can do import, sorry, not import, from date time import date time. So you see we had written date time dot date time now. So I'm saying from this date time import only this date time. All right. So when I say from date time import date time, we can just write date time dot now. So we'll get the same thing. You can also import the module using like this. So when we are saying from random import some function, you can import all the functions using the keyword import random or import random as rn. You can also do from random import asterisk. So this is exactly the same as import random. So these two codes are exactly the same. All right, I'm just showing you to import random in two different ways. So when you write from random import asterisk, you are saying import everything from random. In second line also you are saying import random. So it is the same thing, just you can write it in two different ways. All right, I hope it is clear. Now you can list. Yes, yes.
So this, can we say this? Yeah, can we say this modules as a collection of functions, something like that?
Yes, actually. So if you go to the definition over here, you can see, oh, it's not here. I may have written it. So you see, these are actually files which has been written by someone. It can have some classes also. It can have some functions. It can have other constant values. It can store as an whatever thing you want it to store, not just
Okay.
functions.
So
So
is there any difference between this module and libraries?
when we go to packages, then you will understand what libraries are. Those are
Okay, so
very
it's
simple.
not same.
No, no.
Okay. Okay.
All right, now we will see. So you can just list down everything. So when you say dir random, you will list down every attribute which is there related to random. So these are all the attributes which are related to random. This is just for your information, not necessarily important right now. So you see we used shuffle. So shuffle is here. We used rand int. So you can use uniform also. It is uniform distribution. So when you say rn, we have done random as rn dot uniform. So what it will do is uniform. So what it will do is you will give two values, 1 and 10 I have given over here. So when you go to mathematics, it says that it is uniformly distributed between 1 and 10. You just give me one value. So it will give you some value which is uniform. So the distribution is uniform and it is giving you one value. If you know the mathematics, then you'll understand. All right, so there are we also used randint, so it must be here somewhere. You'll check, it must be here. All right, yeah, it is here, randint. All right, so this is about modules. you have to go inside and see examples of using this random and every other module which you will require. I may not have time to go inside each and every module because there are a lot of modules in Python which may be helpful in specific cases. So if you are programming in a specific area of mathematics, then you will require mathematically inclined modules, and if you are working under some other area, you will require some other type of modules. So, suppose you are working in data analytics, then you will use NumPy and pandas and matplotlib, so those visualization also you will require. So it's very domain specific, and I will go into these libraries as NumPy, pandas at the later part of this lecture. I have planned for that also. So apart from that, each and every module will not be covered in this lecture series. All right. So now we'll move on to recursions. All right. So you see, in the last class, when we were talking about recursions, I told you that recursions are very useful, but it takes a lot of memory. So that was a disadvantage of recursion. And today you will see one example where recursion is very it takes high memory and also takes time because it has to go through solving all the branches. So what I mean, you will see with an example. All right. So before that, I'm importing one module called time. What it will help and how it will help, you will see in just a minute. All right. So I've imported one module called time. Now I'll just copy a code from my file which I have written earlier to save some time. And I'll paste it here. So you see, what is a Fibonacci sequence? First, you have to understand that. All right. So to do that, I have written this code, and this is what a Fibonacci sequence is. All right. So it goes on and on. I have just written the first 10 numbers, but you see what it means. So any number in the sequence is actually the addition of the previous two numbers. So you see 8 is here. So it is the summation of the previous two numbers, 3 and 5 is 8. So when you see 13, it is actually the sum of the previous two numbers, 5 and 8, which is 13. All right. So any number in the sequence is the sum of the previous two numbers except the base cases. So it starts with, actually you can start it with 0, but here I am starting it 1. So 1 and 1 is the base case. From there, if you go on to the third number, you will have 2, which is the sum of 1 comma 1. All right. And I'm saying it the first number is 1, so I'm saying this is the 0th number. All right. So as in list, we see the index starts with 0. So I am stating that the first number is the 0th number in the sequence. You can start from anywhere, but whatever code I have written, it actually takes the first number as the 0th number, the second number as the first number, and then this is the second number, this is the third number, this is the fourth number, fifth number, and so on. So when you write Fibonacci, when you write Fibonacci, give a number, say 3 or 4 maybe. So when you say 4, so you go 0, 1, 2, 3, 4. So this is what we will get. Yeah, we got the same 5. All right. So I have started with 0. You can start with 1 also. It is your choice. But the sequence should remain the same. Any any number must be the sum of the previous two numbers. This is what a Fibonacci sequence is. And the history behind this Fibonacci sequence is very interesting. If you get time, do read it. Where did it originate from? Actually, there was a scientist studying the reproduction rate of rabbits, and from that these numbers emerged. It is a very good and elegant history of this sequence. If you get time and is interested in that, you go, please read that. All right. It is nothing, it is not related to the programming which we'll do today. All right. Now what this code is doing, you see, there is a function definition called Fibonacci, and it returns. So I have written a compound statement here. If you want me to write a simpler statement, I can do that also. So let me do that. All right. So it says if number is less than equals to 1, then return 1, else return this. All right. So this will do the same thing. Oh, sorry. Yeah. So what it is doing is, you see, it is saying it takes one number, which is the argument of this function, and it checks if the number is less than equals to 1 or not. So why we are checking less than equals to 1? Because we are defining the base case. If we are seeing the 0th number in the Fibonacci sequence, it should be 1. So it is returning 1. If we are seeing the first number in the Fibonacci sequence, it should be 1. So we are returning 1. All right. So if it is the 0th number in the Fibonacci sequence, we are saying it is 1. If it is the first number in the Fibonacci sequence, we are saying it is 1. All right. So these are the base cases of recursion. If you recall our last class, we told you that you should have a base case and a recursive formula. So this is what the recursive formula of this Fibonacci is. So for any number, you see, you are saying that fifth number, suppose, so this is the fourth number. So for this fourth number, this is given by the sum of the third number and the sum of the second number. So this is what it says. Fibonacci number minus 1 plus Fibonacci number minus 2. So whatever this value is plus whatever this value is. So this is a very simple code, a recursive code, right? So Fibonacci of n is Fibonacci of n minus 1 plus Fibonacci of n minus 2. So this is how this code is working. I hope this is clear. Any questions? All right. So what this code is trying to do is it is trying to print. Actually, I have given 10, but we are starting with 0. So it is printing the first 11 numbers of the Fibonacci sequence. So we are saying for number in the number of terms, print the Fibonacci number. So so first it will take 0. So 0th number of Fibonacci sequence is 1. So first number of Fibonacci sequence is 1, and so on. It is printing. So I've shown you what is the fourth number of the Fibonacci sequence, which is here 5. Why? Because it is starting with 0. So 0, 1, 2, 3, 4. Fourth number is 5. All right. So this is one code I have written. Now, if you see, so let me write it. So if you see what time it is taking, so you can do that. All right. So this is why I have imported this time. So import time helps me to get the difference between the start time or end time. So when you say time dot time and give a parenthesis, so it will tell the time now, but in computer language. You will not be able to understand it, but it is computer's interpretation of the time, that is when it is executed. This code is executed. So when you execute this, this is what the computer understands by now, whenever this code was executed. All right. So this will help me take the difference between the times. So I'll say start time is this, st is the start time, and I'll say print, I'll say so Fibonacci of maybe 40, maybe 40th number. Oh, all right. And I'll say end time et is equals to time dot time. So I'm just taking the start time before the function call and the start time, end time at the function call, and I'll print time taken is actually end time minus start time. So whatever this time will be in seconds. All right. So this difference will be in seconds. Now I'll just run this code. It may take some while, so just bear with me. All right. So let it run just a minute. I'll just edit the next code which I have written for Fibonacci. Yes. So it has run, and you see this is what the 40th number of Fibonacci is, and this is the time it took, 36 seconds, 35.58 seconds. All right. Now I have written another code for the same Fibonacci sequence, and I'll run it for Fibonacci of 40. All right. I'll explain the code a little later. Just let me run it. All right. Just let me run this code. So I'm running this code, and you see, oh, what did I do wrong? Fibonacci missing. Okay, comma D. Yes. So you see, it took 0.0006105 seconds and it gave the same number 165580141, and this time may vary depending upon your system. So I am running in MacBook, so it is taking less time. In your system it may take some time depending upon the processor you have, but the difference will be clear. If it is taking 1 minute, so it will take very less than 1 minute. All right. So why is this efficient code? But it is still running a recursive program. All right, so let us see what is happening. You see, when I'm running this previous code and I'm trying to calculate the Fibonacci of 40, for 40, it has to have a sum of 39th term and 38th term. For 39, it has to have the sum of 38th term and 37th term. Similarly, for 36 also, it has to take two terms. So if I draw a tree, for 40, it has to calculate, I should write a pencil, I guess. All right, just visualize. So for 40, it has two branches. For 40, it has to calculate Fibonacci of 39 and Fibonacci of 38. For 39, it has to calculate Fibonacci of 38 and Fibonacci of 37. For 38 also, it has to calculate two branches, Fibonacci of 37 and Fibonacci of 36. So you see, we are calculating Fibonacci of 38 two times, over here and also over here, where we are trying to calculate Fibonacci of 39. So there is inefficient use of memory. We are
So I think you are drawing something, but we are seeing your web page.
all right. So just okay. I'll draw in the internet because I don't have my iPad here. Just give me 1 minute. Online whiteboard. So I'll try to draw using my mouse. I guess it will be clear. So you see, so first we are trying to calculate Fibonacci of 40. All right, it is difficult. Just bear with me. I don't have my iPad over here. All right, so for 40 you require two Fibonacci's, which is 39 and 38. Oh God, yes, and 38. All right. Now for 39, you have to calculate Fibonacci of two numbers, which is 37 and 38. This is 37 and this is 38. So just see how the branches are growing. For 38 also, you have to calculate two Fibonacci's, 36 and 37. 36 and 37. All right. So now you see, if you go down, the branches increases. Moreover, you are calculating 37 over here as well as over here. You're calculating 38 over here and as well as over here. Now you will calculate 36 over here and you will calculate 36 over here also and over here also. So it is just inefficiently calculating this branches again and again and again. It is just not very efficient. You're calculating the same thing again and again, and which is taking a lot of memory. And you have to execute all the branches before you come to the calculation of Fibonacci of 40. Is it clear? Or should I draw 3-4 more branches?
Yes, sir, it's clear.
Now,
Yes.
now to take the advantage of this, what are we doing is we are storing the values. So what we will do is whenever we have calculated the Fibonacci of 37, we will store it. And whenever we encounter Fibonacci of 37, we will say we don't need to go in the recursive definition of Fibonacci of 37. Just use whatever we have for Fibonacci of 37 and plug it over here. So whenever it is a very large number, you will see a lot of branches emerging, and we will calculate Fibonacci of some number many number of times. So instead of calculating those number of times, we're just saying just store whatever the number Fibonacci of that number is, and just give it whenever we say Fibonacci of that number. All right. So in the second code, we are doing that using a dictionary. So you see, we will go to this code a little later. Just see what I have done. I am saying there is a dictionary called D with zeroth. This is the key and this is the value. If you remember, key value pair. So 0 is the key and 1 is the value. So 0th number is 1 and the first number is 1. All right. So in Fibonacci, the 0th number was 1 and the first number was 1. Now from second number onwards, we'll just use the Fibonacci definition. So we'll go to the function call and we'll see what are the arguments. We're saying the number itself, I have given n over here and the dictionary I'm passing. Now I'm saying if the number is in the dictionary, if you recall how we found if some key is there in the dictionary, we used in keyword. If it is there, you don't need to go to this definition of Fibonacci, just return whatever is there in the dictionary which we have stored. All right. Else, if it is not there, just calculate this with two function calls. And at each function call, we'll have n minus 1 and the dictionary which we have already stored, and n minus 2 and the dictionary which we have already stored. Now, whenever we have calculated some value which is the answer for nth term, we just store it. D of n is equals to answer. And this will enlarge your dictionary at every number. So whenever you have calculated, suppose you are saying 27th, what is the Fibonacci of 27? You are storing it and you are using it whenever you encountered it again. Fibonacci of 27. All right. Is this clear or not? I'll just go back and repeat if not. So if you print D, you will understand better. All right. So just let me print D. So when I print D, you see this is stored. So 0th number is 1 and so on till 40th number is this. So whenever it was encountering some number, say 26, so it was giving this number, it need not calculate that number again. That is why this code is more efficient. And over here you can see how powerful a dictionary can be. Any doubt? If this code is unclear, I'll just go back and repeat. So we are doing the same thing. You see over here, we had a code which says that if it is first number or 0th number, return 1. Otherwise, do this recursive definition. In this code, we are saying that if the number is already there in the dictionary, then return the number. Otherwise, calculate this Fibonacci and store it in the dictionary. This is a little bit change, but same logic. If we have the number, then give the number, return the number. Otherwise, calculate it and store it. All right. So I'll just proceed. All right. We have 4 people here. Yes. Now you see, in assignment 1, I have given you one problem of palindrome, and recursion can be used to, check if a sentence or a word is a palindrome or not. All right. So we will write a function which actually checks if a sentence is palindrome or not. So if it is checking for a sentence, it will also check for a word. All right. So I'll just copy the code and maybe I'll give you some time to write also. So this is the code. I have one function called isPalindrome, and it has two functions inside that function, which is two characters, two cars I have written, so it means two characters, and another function called isPal. All right. So one functions has two functions inside it. All right. Just if you want to write it. I'll give you 1 minute, and then I'll explain to you what it does. So in this example, you will actually see that we are using recursion in a problem which is non-numeric in nature. So we have seen that recursion can be used in non-numeric numeric problems, but over here we are seeing recursion used in a non-numeric way. All right. So what is the logic we are trying to do? So you see the logic which there is in this code is you get the first digit and the second digit and check if it is same or not. If yes, then remove both the digits. Then check this digit and this digit. If same, then remove the proceed. Have ended at a single digit or no digit, then your string is palindrome. Otherwise, it is not. So this is the logic which is there in this problem. So I'll repeat the logic again. It is checking the first digit and the last digit if it is same or not, and then removing it, modifying the string actually. Then again it is checking the first digit and the not digit, first letter and the last letter if it is same or not. If it is same, then removing it, and it is doing it until either one digit is remained, one letter is remained, or none letter is remained. If it is so, if all this has been done and no and all the digits were same, then the string was palindrome. Otherwise, it is not palindrome. So this is the logic which is being taken care of by the code. You see, the first function which I have written is actually doing very essential thing, but it is very simple. What it is doing is it is first converting the string into lowercase, which is important because in a string uppercase and lowercase are treated as different characters. So it is first converting it to a lowercase. Now it is stripping it of the spaces and commas and inverted commas, and it is stripping off of everything except for the alphabets. So it is only keeping the alphabet. So it is removing the spaces, it is removing the commas, it is removing anything else, question mark, exclamation mark, it is removing everything else except the alphabets. So what it is doing is it is first getting it to lowercase and then making one variable which is an empty string and saying for each character in this s, for each character in this s, you check if it is there in this string or not, because this is all the alphabets which are there in smaller case. If it is there, then can concatenate it to answer. All right. So when you print answer, you will be able to see what it is getting. So print ans. All right. And you see this string is actually being converted to this string, which is in all in smaller case, as well as spaces are removed, commas are removed, and anything else is removed. All right, a b l e w a s i e r e, everything is removed. All right, so this is what the function is doing. Very simple. Is this clear? Now isPal will check if the first digit, which is s0, is equal to the last digit, which is -1, and it will recursively do that. Now give me 1 minute, I'll explain. So first the base case. What is the first base case? It says that if the length of the string is less than equals to 1, so either it is 1 or 0, return true. That means yes, it is palindrome. So if you pass just one number, one string with one character, so I'll just say this and give up just one character, let's say a. So it will say palindrome because it is one character, it is a palindrome. I don't know if the definition of one character as a palindrome is there or not, but nevertheless we are getting it as a palindrome. All right. So it is saying yes, it is palindrome. Now it is doing return this and this. So there are two Boolean expressions actually. So this is actually a Boolean expression. It is checking if the first character, say this first character and the last character are same or not. If it is same, so this will evaluate to true. It will have a logical and it will call the function again with a string which doesn't have the first character and the last character. This function will be called with two characters removed, and again in that function it will check if the string is of length 1 or not. If not, then it will do this check if this character and this character are same or not. If it is same, then this will evaluate to true, and this function call, which is removing this b and this b, and that string will be given to isPal, and it will check again. So in so on and so forth, it is removing one character at a time, both from the starting and ending, and thus checking till the middle. All right, till the middle character is reached. So these are just clever implementation of whatever we have. All right. So it is not important to understand, not understand, it is not important to realize that you can write this code or not. It is just there to show you how you can use recursion for palindrome also. So if you're not understanding it very clearly, doesn't get bothered. You can just go back to this and you can check. If not, you can also contact me. But the thing I'm trying to make is you can use recursion for other programs also, not just for numbers. That is what I'm trying to give you from this code. Right? Is it clear? Any doubt?
No, no, can go on.
Sir, that is pulse you have given 1 to -1, right?
Yes, yes.
So next iteration, it will take the third position and from last third position also.
So it will be a modified string. So when you say, so just let me show you one thing. I hope I am getting what you're saying. So I'll just do this. S is equals to this thing, and in the next iteration, when I say, sorry, this thing, and when I say s1 comma -1, it is actually a new string. Where did I do wrong? Okay, it's not a comma, this, yeah. So in the next iteration, this is what is passed to the function isPal. All right, so this is stored in s. Now when you do this again, in the next iteration, this is what will be passed to s, and so on. So it is just removing the elements and calling the function again.
Okay, sir, thank you.
All right, so this is the end of functions and modules. Now today we'll talk about error handling in Python. All right, so there are exceptions in Python which is raised whenever you encounter an error, and these exceptions are actually named. So in Python you can check what are the names of the exceptions. So I have written here Python built-in exceptions. So you can check dir and double underscore builtins double underscore, and when you do that, so it will give you, sorry, where did it go? Oh, yeah, so it will give you some errors which are there in Python and other attributes also. So this is a list of namespaces in Python. So other things are not necessary. I wrote this just because to show you there are so many errors: arithmetic error, assertion error, attribute error, base exception, and there are so many errors which are there in Python. And if you go down, then it will have other functions, exceptions, attributes, etc. All right. Now we'll see some exceptions. So what happens? What is an exception? If you write some error in your code, you will get an error. So suppose you are writing some syntax error. So you say if a is less than 3, and when you execute this, you will see that you will get a syntax error. It is saying that expected colon. So there should have been a colon. So this is a way of Python telling you that there was some error which is actually a syntax error. All right, but this error actually interrupts your code and the execution of the code stops. All right, so we'll see how we will combat this situation if need be. All right, there can be other errors also. So if you have a math error, you can get a math error, no, not math error, by division, zero division error can be got when you are trying to divide by 0. So in Python there is something called zero division error. So when you do that, you will get divide by 0, which is not possible. All right, now we'll also see file handling. I don't think we will check it today, but you can open a file using open function, which is open, and give a file name called something sns dot text. So if, sorry, not text, txt. So if the file is there in your drive or folder, whichever directory you are working in, then it will open. If it is not, then it will give you an error. So in this case, sns.txt is not there in my directory, so it will give me an error. So it is saying file not found error. All right. So these are some of the exceptions which I have shown you, which maybe you will encounter in your code. All right. Now we'll see how we handle these errors in Python. So there is something called try, except, else, and finally. All right. So this is try, except, else, and finally. All right. So this is the syntax of try, except, else, finally. Now you see, try, except, finally, these are actually optional blocks. Not try, sorry, except, else, and finally are optional blocks. So whenever you write try, there will be some code inside, and in this code, if you encounter an error, it will go to except. So suppose you are not writing else and finally, you are just saying try and except. In that, in other languages, I guess in Java it is try and catch, but in Python it is try and except. So inside try, you write some code which might face some error. So suppose you are asking some input from the user and you are expecting a integer, but the user gives you a string. So in that case, you will encounter some error, and when you encounter that error, the execution of the block of code will stop and it will go inside the except block. All right. So this is how try and except together works. So we'll see one example, then we'll go on to see else and finally. So let us just focus on try and except. All right. So let me write the code. For try and except, you should import sys. All right. For try and export, you should have import sys. Now you say, suppose there is a list which has 3 values. First is b, the second is maybe 0, and the third is 2. All right. Sorry, over here. Yeah. So this is a list which I have. Now what I want is, I want to divide some number with the elements in this list. So I'll get a for loop because I just want individual elements, and then I'll divide, say, 1 by these elements. So I'll give a for loop for I in lst. All right, for I in lst, and I'll say try r is equals to 1 by this number, which is I. All right, and I say int I because I want to convert whatever is there in that to int. You can do that or you may not do that. It is not necessary, but I'm saying that divided by int I. Now you say print result comma r. So this is the result which we'll get. Now you may encounter some error. That is why you're writing some try block. So you should have an except block such that the user gets some good message. They will understand. So in this case, I am giving the list. In some case, you might get a list from the user. So you should give some message. So except blocks helps us with that also. So you said you write except block and you are printing something. So you're saying print. You say anything, error in division, right? Error in division, and you will say trying again, print trying again. Now when you run this code, you see first it divided by b, which will give an error. So this print will not execute. First it divided with b, 1 divided by this int of b, which gave an error. So this print did not get executed. It went to except block and gave this line, error in division, trying again. Now it divided by 0, which also gave an error, zero division error. So this line will not get executed, print result r. Therefore we got error in division, trying again. At last, when you divided by 2, then there was no error, and this except block was not executed. So except block is always executed whenever you encounter an error. If you do not encounter an error, then you will not get an except block. All right. Any doubt? So in assignment 1, I wrote that you should check for invalid inputs. So over there, I wanted you to do it using if else statement, but a better way to do that is using try and except block. All right. Now you will see what else block does. You write print results in else block. What it will do is whenever try runs successfully, then only else will be executed. Otherwise, else will not be executed at all. All right. So you see, it gave the same result because try ran successfully only for the last entry, and therefore this else block was executed at that time point. So you got result is 0.5. So this is what else is. Else is only executed if there is no error while running the try block. We'll come to finally a little later. Is other things all right? All right. Now let us take 5 minutes break. We'll meet in 7 o'clock at 7 o'clock, and then we'll proceed forward. All right. So I hope you are here. So you see, all right. So since we are here, I'll tell you what finally does, because but I have left some space for finally later on. But you see this except. So I guess I hope you all are here. Huh? All right. So you see, except only runs when there is some error in try block. Else only run whenever there is no error in try block. But finally runs always. So it will run no matter what happens in try block. All right. So this is used actually to wrap up your code or something, some files you have open, you want to close those files, and such cases finally is used. So finally will always be executed no matter what. All right. So you say in finally block. So when you run this, you see in the first iteration finally was run, in the second iteration finally was run, and in the third iteration also finally was run. So finally is a condition or is a case where it will run always no matter what happens in try block. So except runs when there is an error in the try block, else run when there is no error in try block and try block has run successfully, and finally runs always. All right. Now we'll see how we can catch specific type of error. So in this code, you see in the first iteration, we had some other kind of error. In the second iteration, we had some other kind of error. So I guess in the first iteration, there will be value error. We will check if it is value error or not. All right. In the second iteration, we had zero division error. So except can actually catch different kinds of errors separately, and you can actually assign whenever it encounters, suppose I guess this will be value error. So whenever it encounters value error, you can give a specific message. Whenever it encounters zero division error, you can give a specific message, and so on. All right. So this is how you can modify your except block. So I have written some code. I'll just copy and paste it. So this is what the code is, and I'll paste it over here. So this is same as the previous code where we had this list B01 and we had a try. So these are some aesthetically pleasing things I have written. So it is saying the first entry in the list is this, and we are dividing it with this, and then we are trying to print it. So the reciprocal of this entry is this. All right, in the try block. So in except block, we have written three except blocks. First is value error. So whenever we encounter a value error, the message which is printed in the screen is this is a value error. Now whenever we are encountered a zero division error, this will be printed this is a zero error. And all other errors whichever is encountered, I have written some other errors. You can make many more blocks over here. So we have so many errors we saw. File exist error. So if you think that these error may be encountered, you can write except block for that specific error. All right. So this is how you can divide your except blocks in different errors. Now you should see one thing, that whenever these errors are encountered, the execution of the code is not stopped. If you don't give try and except blocks, the execution of the code stops. But over here, there is some message which you are printing that this error is being encountered, but execution continues. All right. So this is a very big advantage of using try and except block, and you should always try to use try and except block wherever you think there might be some error. Generally, when you take user inputs, you should use try and except block, because user may give some other input as to what you are expecting. All right. So this is how you can divide except block in different kinds of errors. All right. Now till now in your code, the error which was raised. So this is a technical term, raised. So whenever the error was raised, Python was actually raising that error. So Python was encountering some error and Python was raising some error, and then you are trying to handle that error. In some cases, not in some cases, generally there may be some case where you can also raise some error. So you want to raise some error in a code. Suppose you want to raise an error, say zero division, not zero division, a value error. So you want some input from the user that should be a positive integer. So you say input, input, and you are taking it in a variable called x is equals to input, and you are saying enter a positive integer. All right. Now you are taking a positive integer from the user. So just write it like this, it will be better. Now, if this is not a positive integer, you want to, right? So you can do two things. Either you can do this and check if x is less than equals to 0, not equals to, less than 0, then raise. So this is the keyword, raise value error, value ERROR. So you should be correct in your spellings. All right. So whenever you do this, then there will be value errors. So I am saying -10. In this case, there will be. All right. Inside this, you should give some string. So you say an negative value, negative value. Now you give -10, and you will get. What am I doing wrong? Is it correct? Yeah. So why is the message not supported between instances of string and integer? All right, you should convert it to integer. The input from the user will be a string. You should convert it to integer. Now this will work. Yes, -10, 19. You will get value error, negative value. So you see, you have raised this error. Python is not raising this error because Python doesn't know if you want a positive number or a negative number. In this case, you wanted a negative number, so you raised an error. Now you might ask a question that this error is actually stopping the execution of the program. Therefore, you can actually write this inside a try and except block. Try and just do this tabs. And whenever this value error is encountered, you write an except block for that. Now you say whenever you encounter value error, so you write except value error as e, so the message will be displayed. So print the message, print the message. You see, when you give a negative number, the message will be printed. What is the message? Negative value. So this message will be printed in the screen. So in this case, you are raising the error. You are trying to tell the user that you have entered some wrong number, and this is not correct. So this is one way to raise an error. I have given you one situation. You might find that this situation is not appropriate, but all I'm trying to tell you is that you can raise your own errors. You can raise many more errors. Suppose you are trying to raise keyboard interrupt error. So there is something called memory error also. So you are trying to raise some memory error. So when do you require some memory error? Let me give you one example first. Let me write it. Memory error and give some message. So this is memory error. ERROR. So there is this memory error. This is a memory error. So these errors are actually there in Python. All right. And what is a memory error? Suppose you have 8 GB of RAM in your computer, and Python will not raise this memory error until and unless you are at the end of using 8 GB of RAM. But you want the user to use only up to 2 GB of RAM. You don't want to let the user use more than 2 GB of RAM. So you can raise the memory error whenever the program uses more than 2 GB of RAM. In that case, Python will not raise an error because it will say that I have memory till 8 GB. Why will I raise a memory error? So in that case, you may be required to raise a memory error. All right. Am I audible?
Yes, yes.
All right. Any doubt? All right. So we have talked about try and finally. So finally will always be executed no matter when you or what you want to do. So I have a text over here, txt file. Let me see. Yes, example.txt. So when you see, suppose we have not talked about file handling, so let me do that. We will talk about file handling in maybe today or not today, if not today, tomorrow. So I'll say f is equals to open. So open is a function which opens a file, and I have example dot txt. So it is there in the memory. All right, sorry, not memory, it is there in the directory. Now I am saying except 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 anything print file doesn't exist, file doesn't all right. So you see here you are required to do double quotes, otherwise it won't work. File doesn't exist, and now I'll give a finally. So finally you have to close the file, otherwise it will be lost in memory. So what happens and how it is lost in memory we will talk about when we see this. So it will be f dot close. All right, now when you run this, so I have this example in my actually example code in my memory, or not memory, in my directory. So if you run this, there is no error, so it opens and it closes, so it doesn't give me some error. And this close always works because it always closes the file. Now suppose I don't have this file, so I say example.1. In that case, you open the file, you are trying to do something inside the program, but this except will be run because this file is not in the memory. Nevertheless, the file will close because we have a finally block in the code, therefore file will close. So you will not have some lost files inside the memory. Memory means RAM over there, because when you're opening a file, it is there in the RAM. All right, so it says file does not exist. So if there is no file, so this line doesn't mean anything, but still it is a better practice to always close a file if you open a file. All right, so this is what finally is. So let's talk about debugging. So generally, just 1 minute. So generally, we debug code. So what do we mean by debugging? So if you have some error in your code, generally it will be logical error. So you try to go back and see where the error is, and you try to remove that bug. So it is called as debugging of code. All right. So generally we debug using print statement. So you see, I was writing print statement to give explanation. So when I was doing Fibonacci sequence, or over here also, so I had written print answer. It was helping you to understand what is the value of answer at that time point. So this is also a way to debug your code. You write some print statements at some time point in your code, and you check what are the values of those variables if you want to check, and debug your code. But there is a better implementation of debugging in Python, and it is more interactive in nature with with something called PDB. So what is PDB? PDB is actually Python debugging. So that is why it is named as PDB. All right. Now, so you see, I'm writing one program or one small function, and we will see how PDB will be used to debug your code. So I'm saying def sequence. So I'll say seq, and it will take one number n, and what it will do is it will print 0 to that number. All right. So I'm saying for I in range n, what should I do? I should print n. I should print n and return nothing. So it will return nothing. All right, so I just given return, it doesn't matter, and I'm calling the function with 5. All right, now you see print I. Okay, now you see we are getting a sequence from 0 to 1 minus n. All right, so this is a small function or a small program just to print a sequence from 0 to n minus 1. Now in this simple program, you just want to check what is happening in between using debugger. So suppose at some time point when the code is being executed, you want to check the values of I and n at some iteration, because you want to check if it is running properly or not. So you can use this module actually called PDB. So you have to import PDB, and then I'll just copy and paste this code, and there will be one line. Let me write it before print, which is PDB dot set trace. So it is actually a breakpoint. This set trace, what it does is it actually gives a breakpoint in the execution of the code. So at this point, whenever the computer encounters this line of code, it will stop for some time and it will wait for your input. All right. So what you can do, so there are some commands which you can write, and there are more commands we will see. So I'll just write the commands over here. This is the commands. So C for continue. So we'll see what it means. All right. So let me show you. So I'm running this code. All right. So I hope this is clear. I'll run the code now. All right. So I'm running it. So you see what it is showing. So what happens is first this import will run, and this function definition will happen, and it will not go inside the function. We have talked about this. Therefore, the execution will come here and the function call will happen. So it will go inside the function. Now the for loop will run, and whenever it encounters, yes. Pratibha, any questions?
No, sir.
All right. So you can mute yourself. Thank you. So whenever it encounters pdb.setTrace, this interface has come where you can enter some commands. So suppose you want to know what are the values of the variables. So when you say p space locals, so this command, if you write, it will give you the value of the local variables. All right. So when you do that, you will see n is 5 and I is 0. So in the first iteration, I is 0 actually. All right. Now you can also write list. So list is a very good command which I use regularly. So in list, it will show you where the point is, where the code has just stopped. All right. So over here it shows. Why is this useful? You see, in large codes, you may have 3-4 breakpoints. At that time point, you must know where the breakpoint is. So why do you need 3-4 breakpoints? Suppose you are modifying the values of variables at some points in your code, and you want to check at each time point what is the value of those variables. That is why in your code you may have more than one breakpoints. In that case, you want to know at what breakpoint this PDB has stopped. All right. That is why this list will be useful. You have p globals. It will give you the values of the global variables. Right. So you. All right. So what it did. Okay, since we have imported this PDB, it is showing you all the variables, so it is not necessary over here. Let me run this code again. All right. Okay, I didn't quit the code, so I have to interrupt the kernel. Have you talked about interrupting the kernel?
Yes, I think on the beginning of the class you mentioned about interrupting the kernel.
All right. All right. So we are here now. We'll again say list. So we'll see where the breakpoint is. So you can see the breakpoint. Now there is something called help. If you write h, you will get all the functions which are there, which you can use over here. All right. So when you write h and when you run, so these are everything which you can use. So I have not used all of this, so I may not help you right now with all of this, but some of the things which I use, I have written it over here. And what is C? C is continue. So if you want to continue with the execution of the code, you write C and it will continue and it will again come back. So you see, you wrote C, it has printed I. So what was I? It was 0 and it came back. So you want to check where it is. So you write list and it will give you where it is. It is actually in the 6th line now. All right. So this is how C can be used. So P can be used to print something. All right, so if you want to print the value of I, so you say pi, it will print you the value of I. So in this for loop, at this iteration, the value of I is 1. So earlier it has printed 0. In the second iteration, the value of I is 1. So P can be used like this. All right. Other things, I guess I have told you. And what is Q? Q is just quit. So it will quit PDB and the code will run as it is. All right. It will ignore the PDB command altogether. So when you say Q, it will run and it will. All right. Okay, it has not run the code, but it quitted PDB altogether. All right, so I was wrong over here. So this is how you can debug code using PDB. So I do not generally use PDB, so I am not very familiar with it. So is this clear?
Yes, sir.
You can try yourself if you want to. I'll just wait for 2-3 minutes if you want. Yes.
So it's too much to try. We'll try it on our free
After.
time.
All right. All right. So I have written some more commands. So actually this I have not written, I have taken it from somewhere. So I had told you about H. H is actually help. W, you can see what W is actually. I guess, let me try what W is. I don't know. So let me try what W is. So what W is actually, print a stack trace with the most recent frame at the bottom, a arrow indicating the current frame with which determines the context of most commands. So actually it is showing you okay, I have to check actually what W is and how it is different from list. I'm not sure. All right, so I have to check these things. I've just copied it from somewhere and pasted it over here. All right, so this is all about try and accept debugging. We talked about a little bit of recursion and also what did I talk about? Modules. Yes. So before going to actually file handling, let me talk about a little bit about packages. So what are packages? You see, whenever you store some file in your computer, you use it into directory format. So there is some folder, inside that folder there is some other folder and so on. So in a similar way, if you store modules in some so again the packages term will come. All right, so let me show you something. I guess if I get package pskgs in Python, yes, this will be helpful. So you see, so it is just like a directory structure. So the topmost folder you can say, but it is actually a package. So it is car. Inside that car you have 3 more folders or 3 more sub packages, which is Honda, Porsche and BMW. All right, and how Python is understanding that it is car, because it has a file called underscore underscore init underscore underscore .py. Whenever a file has some files inside it, but it also has this underscore underscore dot init underscore underscore dot py file, then it Python will understand that it is a package. So what is this underscore underscore init underscore underscore? It is actually an initialization package, not package, sorry, module. So you may have some initialization code in it. So you want to give some features for the car, some values which are um, universal, some things, or you can have empty also. So it can be an empty file also, but there should be a file named underscore underscore init underscore underscore dot py. Whenever Python sees that some folder is there which has some files or folders, doesn't matter, but it has a this file, then it will think that this is a package. And these are also packages which is under car. So this Honda is under car, it is also a package. Why package? Because it has this file __init__dot_py. All right. So this is also a package. This is also a package. This is also a package. Now, suppose you want to call this import this module hij.py. When you want to import this specific module from this package, from car package, what you have to do is you have to write car.bmw.hij. So you have to ignore .py. Similarly, how we ignored py over here. So when we are trying to import this module abc.py, we did not write .py. So actually random is actually random.py file, but we are just saying import random. So similar to that, when you are trying to import some package, some module from a package, what you have to do is you have to write car.bmw.abc. So you see, when we go to date time, you will understand. You see this date time. It was something similar. Datetime.now. So it was something similar. All right. So this is how what a package is. So if you go here, Geeks for Geeks, you will see what package is. Python modules may contain several classes, functions, variables, etc. Whereas Python packages contain several modules. So actually package is a collection of modules. So similar to what we do in directory structure in our computer or mobile phones. We store some files inside folders, and so on. All right. Packages in Python is a folder that contains various modules as files. So this is a little bit about packages. All right. Then if you want me to proceed, then I'll go to input output, file input output. Otherwise, we can do it in the next class, because I want you to write some code using try and except block. And this file input output is completely different from whatever we are doing till now, because this input output of files are actually interacting with operating system. So whenever you are trying to communicate with the operating system, so I have a Mac operating system, you may have a Windows operating system, those communications may be different, because Mac operating system stores files in some other format. A Windows operating system or Linux operating system stores files in some other format. So this communication of Python with the operating system happens, and that process is actually known as file input output. And this communication, or whatever we'll do, is a little bit different from the code which we have written earlier. So I didn't want to start this today. All right, I had written it here, but this is a little bit big section to proceed. All right. Should I start now or next class?
Maybe next class, sir.
All right, I'll take the attendance. So attendance is just decreasing day by day. I don't know. Maybe the course is stretched. So Ranjit is here, Ram Prakash is here, and Kalyavani ma'am is here. So, and I guess Pratibha was also here, so I'll mark her. Pratibha and Vijaya was also here. Yes. All right. So any doubt? Actually, I was planning to give assignment 2, but I am a little bit busy. But I'll give you assignment 2 before the end of this week. All right. So you will get assignment 2, and I'll give 4 or 5 days to submit assignment 2, or maybe 7 days. And in that, I would like you to use try and except block and other function calls, etc. And after, when we have completed this file input output, we'll move on to object-oriented programming. Over there, we'll learn about classes, inheritance, and other things of object-oriented programming. All right.
Okay, sir. Okay.
Anything else? All right. Thank you.
Thank you, sir.